Let's see if we can warm up the mood a bit more. Have you seen this video? Do you know it? No? It's David Bowie's Space Oddity, and it's a very special clip done by a Canadian astronaut called Chris Hadfield. He was probably the last commander of the International Space Station.
Ground control to Major Tom. Ground control to Major Tom. Lock your Soyuz hatch and put your helmet on.
And obviously he did sing it on the space station, and these are space station footage.
Commencing countdown, engines on.
And David Bowie was touched by this interpretation, and he told Chris that this is the best version of the clip and song ever produced.
This is ground control to Major Tom. You've really made the grade, and the papers want to know whose shirts you wear. But it's time to guide the capsule if you dare. This is Major Tom to ground control. I've left forevermore, and I'm floating in a most peculiar way, and the stars look very different today. For here am I sitting in a tin can, far above the world.
The greater thing about including musical videos in your presentation is that you have to speak less. It takes a lot of time. It consumes a lot of time. If you won't have any questions after the presentation, then we probably can play the video to its full. But the reason I picked this song and the video is that I really believe doing hardware startups is very much like doing something that is related to space, like a spacewalk. And there will be several comparisons between software startups and hardware startups, because most of us have a background in software, either on the business side or the engineering side, but it's different. And if you get the concept of the spacewalk and how dangerous it is, you will be much more successful with your hardware startup. So first of all, what is a startup? By definition, think big, grow fast, scale, and start small. But for hardware startups, scale fast is almost impossible. It's almost the same amount of effort, resources to produce one piece of equipment than to produce 100,000 pieces of that same equipment. So in the classical way, hardware startups are not startups. They are starting companies, small companies, wannabe enterprises, but they are currently called hardware startups. So bear in mind that you won't scale that fast. Who knows this guy? Nobody. Okay. And do you know what is the picture he's photoshopped into? It's from Space Odyssey 2001. He's actually posing as Dave, one of the lead persons in the movie. The guy just announced his new hardware startup, flying people to Mars. And if you imagine that it is also some kind of hardware startup, then you can imagine how hard it is to run such a company. Tesla didn't start with the Model S or X. They started much earlier. And it's very hard to understand the difference between running a successful hardware business and software business, but I picked the spacewalk and creating the omelette. For the spacewalk, even if you are trained for 20 years, it still takes 2 or 3 weeks preparation time for just one spacewalk. For an omelette, it takes probably 5 minutes of preparation time, and if you fuck up, ditch it and do it again. That's what software startups can do. They can iterate again. But a hardware startup has to provide the user, the customer, with something that almost resembles the end product to get actual feedback. And if you put it out there, you might not get a second chance. That's why I compare it to spacewalk. I created a small chart or model to dissect the whole process of creating something. I know this really doesn't relate to software startups, much more to the phases of a hardware startup, but stay with me, okay? And you will see both the differences and the similarities between software and hardware startups. So the first phase is creating something we can show people. That's called the MVP in the software terms, but the same level of MVP won't fit any customer or any hardware project. You have to create a prototype, a working prototype, something that looks and feels like a duck. You know the story. If it looks like a duck, feels like a duck, and quacks like a duck, then it's probably a duck. And with software startups, you can create a mock-up, wireframe, anything you want, even a PowerPoint presentation with good graphics that almost resembles how it will work, how it will function. But with a hardware device, it's impossible. If I tell you a drawing, just imagine a Kickstarter campaign with a video. You see it, you try to imagine how it works, how it would feel to touch. But in the end, when you look at it, it feels cheap, it doesn't feel comfortable, and so on. The next phase is how to scale it. For hardware startups, scaling means manufacturing, creating several thousand, several 10,000, or several million pieces of the same equipment for the same quality, or with the same quality. If you're running a successful or want to be successful software startup with continuous deployment and development, you can easily iterate between the functions, versions, and create new, create new versions of the same software, and really iterate the hell out of the market. There is no extra cost involved in the new version of the product. Just the human effort put into it. Imagine the same with a hardware startup. Molding tools costing something between 10 to 40,000 euros. Prototyping, coating. Maybe you have to apply for new TÜV, CE, or FCC, and it all costs money. Also, software startups usually don't have patents. I will get back to it why it's very important that you might have a patent pending, or a design patent in a hardware startup, and how it can influence your go-to-market strategy and just generally the business model. And the last part is when you are trying to sell it. It's a very integrated part if you're running a software startup. Actually, the 3 phases are a small circle. You create the MVP, put it out on the market, try to scale it, attract customers, then change the MVP. Again, customers, feedback, iteration, MVP, or it's not MVP, but further versions of the same software. But with hardware startup, selling it is actually the end of the product. Because when you're selling it, it means you're done with it. The new iteration will be a totally new product. It might be called version 2. The first one was light. This will be the full, or SME, enterprise, whatever. But it's a new product. There is no such thing that I roll out a product and sell it on Amazon.com and the new version will be the same product. Because of the reviews, because of the stuff involved, like software. Look at one example is Google Nest. They started with the Nest Smart Thermostat. Version 1, version 2, and now they are at the third generation or so. And they are manufacturing it in large quantities. This is probably the picture I hate most when people are trying to tell other people about the lean method. Because if you know the lean method, this picture has a message to you. If you don't know it, 99% you get the wrong message. Because none of this is lean, actually. But the concept is that you are trying to build something that is useful and iterate it until you find the right product market fit and find the right product, the right feature set, the right use case. That's what the lower figure is trying to show you. But the upper figure is how you can do lean in a hardware startup. You try to dissect the whole concept, the product. Maybe it's just hardware, software, hardware, embedded software, mobile application, and you just dissect everything into small pieces and try to iterate these small pieces, like input method, user interface, design, casing, materials used, coating, and you try to iterate each and every phase. But still, the experience is not the same when you are sitting in a whole, fully functioning car. And that's one of the points most hardware startups miss when they start to do something. They are trying to be lean, but you can't be lean because customers are buying the experience and not some kind of MVP. You wouldn't buy this presenter if it was out of paper. You would say, okay, it looks nice, works nice, but you know, guys, if I put it in my backpack, this will go totally crazy and probably the battery will flat out. So customers are buying the minimum viable experience or valuable experience, and that's what you should design for. If you are trying to iterate a hardware product, focus on the customer experience part and how you can dissect the whole product into small experience pieces. You have a full feature set in your mind and try to test the features separately from each other. I will show you something that probably in 2 years will help you become more lean with regards to hardware startups. But generally, that's the idea, that for a software startup, you can create something that works very cheap, very fast, and you can iterate that. But with hardware startups, you have to dissect it to small functioning items. And still, if the small items or the small pieces work, and you get the positive feedback, it doesn't mean that when you are putting it all together, you will get the same positive feedback, because the experience is totally different. Imagine the buttons, the screen, the design, tested all separately. It's not the same as the end product. I don't know if you will get the slides, but this is just some kind of summary about what I was talking recently. And this will be presented in the handouts you might get after the Vox days. So, what you cannot do and what you can do. If you're running a software startup, you have access to a lot of knowledge online. For hardware startups, the knowledge is at engineers who have been running the business for 20 years. It's not online. If you want to know about molding, you have to go to the factories and talk to people, talk to engineers. Because the only way to get 20 years of engineering experience is to work in the field for exactly 20 years. There is no cutting the corners. If you're running a software startups, you go to Stack Exchange, online, GitHub, whatever, you find code, you find people who can tell you more about the code, or if you look at the code and it's well documented, you can understand it. There are small pieces you can use, reuse, repositories online, everything. But for hardware, you might get some devices from China. It might work, it might not. You don't know how to source the things from China, where you can find the items, whether the new platform will fit you or not, and it all takes money and time. And this kind of experience is very, very well nested in the engineering department of any electrical engineering company or hardware company. But you as a startup have to go there and pick their brain. Because otherwise you will pay very, very hard for the lessons learned. The one very, very obvious and often neglected benefit and feature of running a software startup is A/B testing. It's extremely complicated and even more expensive to do any kind of A/B testing for any product or hardware-related startup. You can A/B test the user interface, you can A/B test the mobile application that maybe goes with the hardware, but A/B testing hardware and features, it's not as simple as signing up for a service, $50 a month, and just pasting 2 lines of code into your product, and all of a sudden you have A/B testing. It's not that simple. Software startups don't have any kind of retail issues. You have app stores, and you have app stores. And you have app stores. So if you can make it in the app store, you will be lucky. If not, well, then you have to make it in the App Store. And I want to cover the IP part here. Hardware startups are different from software startups that they have IP. It's always a decision whether you want to protect the IP or open it up, make it open source, and make it accessible to everybody. Most startups I work with are trying to patent things, and the issue is that when you're trying to patent something, it will add value to the company as soon as you have traction. The misunderstanding is that when you're filing the patent, it doesn't add any value to the company. Exactly $0. But when you are able to sell something to 100 people or 150 people or maybe more than 1,000 people, then the patent will skyrocket the valuation of the company. But not until that point. And the patent can be very, very disadvantageous for your journey forward, because you always have to think about whether I want to publish this article or not, whether I want to go into details or not. And especially in the early phase when you are trying to get traction, get followers, and get the social media going, the buzz and the hype train, you don't have anything at all. Because probably the design is right under patent, you are just preparing for filing the patent, and you don't have any feedback about the genuinity research, whether it's something new or not. And then you really can't do anything else, just put some cat videos on your Facebook page. And that's going to give you a lot of clicks, but not move your business forward in terms of potential customers. Hardware startups tend to use Kickstarter. It's getting crowded, it's not yielding the results it used to be. I worked with a company called Ultimate Hacking Keyboard. It's a keyboard from 2 separate pieces with several functional layers. It's designed for coders, and they successfully closed the campaign of $260,000, but not on Kickstarter, but on another platform called CrowdSupply. And all the terms have changed. The key difference is that CrowdSupply asked for a working prototype. I know that Kickstarter and all the crowdfunding sites are changing right now, and they are asking probably for the same level of readiness of the product. But still, people consider Kickstarter as either a platform for funding or a platform for selling your product. So if you are in a prototype phase, you create a video, and if enough people sign up, then you start manufacturing. Or several years ago, you just create a video with a concept, and if you get a lot of backers, then you start wondering, okay, how the fuck we are going to make it? I mean, the rendering looks cool, but somehow the 3D printing and the molding doesn't look that cool. And how we are going to tell our customers that it's all rendering and it will never look that good? How we are going to deal with that? And Kickstarter is a great way to test the market, nothing else. Just to see if your communication, your market fit, and just the value proposition gets traction or not. It doesn't tell anything about the product. They don't want to join us. What I used to say is that Kickstarter or any crowdfunding campaign is just the same as a landing page for a software startup. You can't measure whether people will like what you do, but you can measure whether the problem is there or not, and whether you are able to communicate the one-liner. Is the one-liner good or not? Are people clicking and backing? Yes, no. Kickstarter also has the advantage to test the price point. Is this price level okay? Yes, no. But unfortunately, you cannot A/B test the price level if you're running a Kickstarter campaign. That would be probably very, very fun to see, just by adjusting the price level, how the conversion rate changes. But they don't allow that. And physical goods are physical, and hardware is hard. And I will try to come up with some more cliches, but I picked the 5, or actually the 4 biggest Kickstarter campaigns by the number of backers. Pebble, these are projects that were hardware startups. So consumer-facing products with at least hardware and probably some software involved. And you can see that the original Pebble had 85,000 backers and altogether 250,000 pre-orders. Ouya gaming console, 65,000 backers And from that point on, a big crash. And the third one on the podium is Oculus Rift with 10K backers. And then Block's smartwatch, which you can see on the right, had 5,000 backers. So probably you can calculate with something between 1,000 and 3,000 backers. And to put that in comparison, how small that number is and how big challenges you will face with even those small numbers is Apple Watch, 12 million pieces sold. It's much, much more. And they didn't make a Kickstarter campaign. They have a good brand and they have a huge retail. That's all. This is the message I want you to remember. So Kickstarter is nothing more and nothing less, just like a landing page for software startups. The hard part about hardware is that you have to deliver. It's not like you shut down or you decide to pivot. Okay, we started a B2B software startup, SaaS startup, but now we are doing mobile application development or outsource development. If you put several years into a hardware startup, you want to deliver. You want your baby, your product to be exactly how you started. And there is much, much less way to pivot out of a hardware startup than to do the same with a software startup. And it gets important when you have to deliver, because even 100 or 1,000 pieces of equipment, to deliver it from China or from a local manufacturing company all around the world means a hell lot of problems that a usual software startup is not going to face. And I have seen several software startup founders fail at this point because they didn't calculate the price, the time, and the risk of shipping and shipping related legal work. And of course, the biggest risk is, I don't know, do you know the story of Hanjin? No. It's one of the biggest container shipment companies around the world. Not like Docker. So they are actually physical containers, which they are moving. And they are moving a lot of stuff from South Korea and China, Taiwan, to European and American ports. And Hanjin recently collapsed, went bankrupt, and they couldn't go into the ports. So a lot of LCD TVs, digital goods, stuff got stuck on the sea. Literally between ports. And until the port was paid, the ships were not allowed to sail into the ports. So that's something you have to face if you are running a hardware startup. That the lovely people in China or Taiwan did prepare your stuff, but the other lovely people didn't deliver. And you have to be standing good for their mistakes. It's not like, oh, you know, there is a hiccup with Amazon, but we'll be back in 5 minutes. You have no idea when you are going to deliver. And sometimes you don't even know on which ship your good is. Talking about marketplaces and delivering stuff, the only similarity between a hardware startup and a software startup is that there is only one concentrated marketplace for hardware startup, and that's Amazon.com. Amazon Marketplace works very similar to App Store. You need hacking, you need search engine optimization, you need to hack the reviews, you have to be prepared to make price deductions, introductory price. So It's really about a special field of knowledge, which again, hardware startups usually skip because they believe, okay, we have a very good product, which we are either going to sell through our online shop, or we are going to some of the retailers or wholesalers and use their channels. And when they meet these wholesalers and retailers, they realize that these companies take up 50 to 70% of the margin or the suggested end user price just to put it on their shelves. And then they realize, okay, we don't have the margin to afford retailers. How we are going to sell it? In a fortunate case that your hardware is working and the manufacturing issues are resolved and it's delivered. Well, you go to Amazon and then you realize that it's a totally special knowledge which you won't learn in 1 month. And it's going to be expensive to hack Amazon. So you have to hire somebody for which you don't have the budget, usually, by the end of the product release. Cool. Yeah, just like the MasterCard ad, for everything that is not Amazon, you have retailers. Back to manufacturing. When you have a working prototype and the user feedback is positive, you do several iterations with the same prototype, but the show starts when you have to turn this into manufacturing. And the reason I chose these 3 phases is that whenever I talk to a hardware startup, I try to tell them that there are 3 types of risks involved in running a fully fledged hardware business. And the 3 types of risks are: can we do it? Is it technically feasible? Can we solve the challenge? Create oxygen out of water? Can we do that with a mobile application and a small sensor? If you can do it, it means you have a working prototype. Can we scale it? Can we prepare it for manufacturing, for mass manufacturing? Yes, no. This is also special knowledge. And I haven't met any startup who has this kind of knowledge. I don't have it either. Again, this kind of mass manufacturing knowledge is at the mass manufacturing companies. And you have to involve them at quite an early stage, which will give you headache because you don't want to share sensitive business and technical information. But without those technical informations, they are not able to provide you with technical feedback. And you design your prototype. And all of a sudden you realize it cannot be mass manufactured. The lovely design, the chips, the electrical board, it won't work that way. Or it can be manufactured, but by another company, which again takes 3 months of negotiations, and it will be twice as expensive. And then you realize you're out of money, or you have to raise the price level, which your users or your customers maybe won't like. And the last one is the risk of selling it. A lot of hardware companies don't have the business skill set to understand customers, create great value propositions, and also consider the pricing. Just like with wholesale, retail, several and different price levels, margins, and make calculations based on the equipment used. So a lot of hardware startups get stuck in either the first and the second phase. So they are able to prepare for mass manufacturing and probably could even get the money on board to produce several hundred pieces, but they cannot sell it. The online sales, the Kickstarter campaign, whatever they picked, didn't really work out. So they have to go to the retailers, but they don't know anybody there. It takes another 6 months to meet the right people at the right companies. And then you realize that your price level is not competitive enough to involve retailers. You have to deliver. Either you hire a fulfillment company, which again takes up several % of your margin, which of course you haven't calculated, or you do the fulfillment yourself. Then you have to deal with warranty issues, packaging, and with packaging comes again legislation, because for different packaging materials there are different local legislations. So it's, for a hardware startup, it's much more complicated than a software startup. And my advice, if you want to really get to the end of the story, is to somehow change the lean method for a hardware startup. If you have a great idea, try to come up with something different. And try to learn and understand the risks of the first phase, just by creating the prototype. With one of the companies who had an IP, a patent pending, and didn't release any kind of prototype or product before the patent was actually filed, the first real mass user test was 1 week before the estimated mass production start. And when 25 people touched the device and interacted with it, they realized it's really not finished yet. So applying the lean methods for hardware startups is to dissect the whole process into small segments and iterate those segments and not the whole process. And iterate the first segment until you have enough experience with creating the prototype, doing user tests, filing patents, so you can move on to the next step. And you can learn by doing several manufacturing preparation processes how to do it. So you get the experience and the knowledge. And then again, you try to do the retail, the sales, the different sales methods. Or you bring a lot of people on board. A usual software startup starts with 3 people. It's usually less than 2 if you believe the statistics. But usually, or what VCs like to see are 3 people. And if you want to run a successful hardware startup, it's probably something between 10 to 15 people. If you want to eliminate every type of risk, you will need 10 to 15 specialists in your team. Legal staff, retail staff, Amazon guy, Kickstarter specialist, designer who can actually design the casing and molding and all the stuff, manufacturing specialist, and the list goes on. So this is why hardware is hard, and it's very, very complicated to do anything with it. And I was much faster than anticipated. So you will have the chance to start launch earlier. But if there is only one question you have to ask yourself each day, is that, what if this is a spacewalk? Would I do it the same? Because we tend to ignore most of the risks and issues. And in spacewalk, you cannot. You can't you can't mitigate the risk. You have to be prepared for it, and you have to learn, and you have to do a lot of technical preparation for it. But it's not something you can do again or again, because if you've released a bad product, it will ruin your reputation. If you're doing it on Amazon, then probably you won't have a next chance just to rebuild a new brand with a new product. So what Chris Hadfield, the astronaut, told in his book is you have to change your perspective. So if you're coming from the software field and want to be successful in the hardware field, you have to change your perspective to be able to apply everything that you have learned. There is a lot of good stuff coming from the lean startup method and the running software startups. But if you believe that your experience with software startups will translate 100% into hardware startups, you will fail. You can ask around or later after the show. I can tell you several companies that failed because of this, or at least I believe because of this. And my understanding working with software people running hardware startups is your experience with software startups translates to something between 10 to 20% into a hardware startup. Not more. And that's all. I have one more thing coming, and that's how you can make probably several years later a successful, really, really lean hardware startup. So apply almost everything you have learned in software startups, and that's augmented reality. Virtual reality and mostly augmented reality. Just imagine that you have some kind of controller in mind, and all you have to do is 3D print the design. And then you can replace every instrument on the device itself. You want a screen, you put up a screen, and you let people try it. And that's what I believe the augmented reality will change. That's what I believe the killer feature for augmented reality will be. Because augmented reality in the end will be business use. Virtual reality is for entertainment, and augmented reality for B2B and business use. Thank you. Questions? Did I tell enough about manufacturing issues?
Yeah, maybe a little bit more about all this shit about FCC.
You want to know about more?
I mean, how complex I know.
So it's about FCC, CE, TÜV, and whatever acronym you can come up with. It's complex. Nothing you cannot learn or try. It's just, it takes up a lot of time. So either you pay someone who is a specialist in this, and they will prepare the documentation for it. The problem is, if you want to sell it in the US, FCC, FDA, and there are some others. If you want to sell it in Europe, then comes CE, Aero HS, so LEED and lithium-free, environmental standards, and stuff like that. And for every country that you are selling to directly, you are responsible in terms of legislation and environmental impact. So you have to do the research yourself. Palm, do you know the company Palm? Yeah. They were making handhelds, and they decided to close up the European offices. They didn't sell Palm in Europe for the last 5 or 6 years of their existence. Why? Because for every country, they had to make one call center. And that's especially problematic in Europe. The other, even though it's European Union, there are a lot of different rules. And it was very expensive to keep up with. So if I were you, I would start with an American market or India or China that is just one legislation and big enough to start with. Did it answer your question?
Yes.
3D printing helps in the prototyping phase. There is a very special SLS printing. It's laser molding. So they are using lasers to put together particles. And it very much resembles the actual molding process, because in the end, most of you will do molding, so create something out of plastic. And if you can print it with SLS, then it's probably moldable. A lot of guys fuck up with the design that it's beautiful, but it cannot be molded because they can't create the tools for it, or it gets very complex. So yes, 3D printing helps, but one iteration with this SLS, which is on a 1 micron, I guess, so that precise, is for such a small device like this. It takes something between $500 to $1,000. One printing. And you know, the rendering looks good, but when you print it, you realize that small tiny bit. One of the clients created something that is handheld. And I told them that a great design is when people are picking it up the right way. You really can't hold this mic in any other way. People make changes how close to you put it to your mouth, but that's use problem. But you don't hold the mic like this way because it's well designed. And you create something that looks gorgeous. You print it, you put it in front of people, and they pick it up like this. And then you realize, okay, the design looks good, but it doesn't serve the user. It doesn't help me sell. Because if I have to create a booklet on how to touch it, then you have to create some kind of onboarding process. I thought that I would be much longer, but if you don't mind, I just talk a little bit about the onboarding process, okay? For each hardware startup, one of the most neglected part is where you can make up some space which you fucked up with manufacturing or design is the onboarding process. And for hardware stuff, the onboarding process includes packaging, and it can also include some kind of web page. What we did for Ultimate Hacking Keyboard is that when you open the packaging, there is a very big sign where you can start using it. And if you go to the website, it tells you, okay, plug in your keyboard, you will see this and that, and then start doing this. And we figure out what are the 5 or 6 things that people actually are able to do themselves and create a learning curve. Because a lot of hardware products are not so easy to understand for the consumer. So, and people will not read the manual. I know, read the fucking manual, but they won't read it. So you have to create some kind of invisible manual, which is packaging again, something they have to remove from the device to make it work. Or if you realize that people are not finding how to switch it on or off, put a huge sign on it, or something like that. Or if people don't know how to hold it, then put somebody on the packaging holding the product. And that's kind of onboarding brought from software startups. And this is a way, way cheaper method to solve design issues than to create a new design and mold it again. More questions?
Yeah, I've got a question around patents. I've actually got a friend who came up with a product, and she wanted to get a patent for it. How valuable actually are they? Because if you're actually going to the manufacturing phase, you are talking to manufacturers in China, in Taiwan, where intellectual property laws aren't necessarily as cared about as they are here in Europe. How do you get around that? Like, is this valuable from preventing competitors from building your own product but better?
There are several phases. First, if you're doing the patent filing yourself, preparing the documentation, probably it's going to be very low quality. So you have to work with a professional. The key to patents is to be as vague as possible. Because if you're specific, then it's easy to go around it and create something new. That's the first one. So find somebody who already won a patent issue. I mean, it was brought to trial, and based on his patent filing, they did win. And work with this kind of professional. China has changed a lot, so yeah, intellectual rights are not at all high in China, but if you don't have traction, it has no value. Either in B2C, or if you are trying to license your product or sell it to other businesses, they will look for user traction, tests, or that you were able to sell 100 pieces of that, or that people could easily use your technology. So kind of technology acceptance test from the user perspective. And this kind of videos or tractions make it valuable. And the market will tell you how much it is worth. Did it answer your question? No?
I get the impression that this is actually much more complicated than it seems, and that the patent itself, as you said, it only really has value if you're selling it, and then if you want to file a patent, prepare to defend that patent legally as well.
Yeah. And it's easier to get VC money on board if you have patent. So from that perspective, it's absolutely a must. And we can talk about it later.
Can you share a good example of prototype testing, testing the prototype on the market, like the first iterations of the prototype?
Okay, I always create groups of 20, 25 people, and they don't know what they will be testing. So there is always one-on-one test. We do video record face, hand. If it's an interaction with the software, then it's usually on a notebook. And there are 1 or 2 engineers always present when the customer uses. So there is no focus group test, no group test, no nothing. And then the customer has 3 to 5 minutes max. Because if they cannot use it in 3 minutes, it's not like they are going for a training to buy your new device. So that's how we use it. And it 3 or 4 hours you can test with about 20-25 people. I use meetups for that. So I organize a hardware testing meetup and people sign up. That's how I do it. Did it help you or no?
Yeah. Is it this mostly usability testing or also testing if people would actually buy it later?
No, it's just usability testing. Because you get a lot of impression on how they use it, what they understand of it, and it helps you in the value proposition as well. So, yeah, you can ask whether they are going to buy it or not, but it doesn't mean a thing. What means is how they understand, how they will going to tell others about it. Because if people enjoy using it, then it will have traction. And for this kind of test, you have to test whether people are enjoying it, or how can I make people enjoy it? What kind of onboarding, what is necessary to make people happy with the product? Yep.
Hi, so I wanted to ask you something. Like, it's quite clear that right now actual availability of capital for software startup is much higher than for harder ones. actually, because of the risk involved. What do you see, I mean, in the future, considering that all real problems will be
IoT.
solved by hardware?
IoT.
Yeah?
I believe that the end of the software development will be that there are so few developers that in the end somebody will create a new language from which you can drag and drop everything. And because of this, software startups will lose value. Probably not in 1 year, but maybe in 5 or 10 years. What is currently done by developers will be done by my little sister. And that's when a lot of money will flow into hardware startups.
And one other thing is, I was thinking like a lot of successful startups, I mean, the one you showed with Elon Musk, it's kind of ironic that all of his actually ventures were funded by his previous successes in software startups. And that's the case for a lot of these guys, actually. They made billions, actually, in software, and then they tried solving some hard problems in the world of atoms, as they say it.
Yes.
So I'm just curious, and even by then he had to put basically all of his money for Tesla to succeed. They also went bankrupt. So a lot of risk, and I don't know, how do you see immediate future, maybe next 3 to 4 years? I mean, what will change in the landscape with augmented reality and virtual reality becoming,
It will be easier to test.
Mm-hmm.
So you can go to make usability tests, make design tests, and probably go to a VC and show them with an augmented reality device, okay, this is what it looks like. So you will save a lot of money on prototyping. That's how I see it, that the cost of prototyping and reaching the final pre-mass production phase will be probably 1% of the current. Okay?
Thank you.
Thank you very much, guys. If you have any questions, you can talk to me later.